Okay, so in this is sort of, it seems like it's a weird aside, but here's what we're doing. We're setting up the rest of the chapter. Okay, so we're going to set this up in concept. So let's pretend I have a bicycle factory, right? And I need to build bicycles. Now I don't know much about bicycles. I like riding bicycles. I usually ride one every day, right? But if I wanted to make a bicycle, I'm a little hard pressed. Okay, but if I was to write a balanced equation, I might write a balanced equation that looks like this. That's a frame, right? And then how many wheels? Well, you need wheels, right? And then from that, you should be able to make a bicycle. Okay, here's, yeah, I know it's horrible, but anyways. So here's the deal, right? That's not balanced, so I have to put a 2 here. So this is wheels, and this is frames. And if I were I can't talk. If I was to write this as a balanced reaction, it would look like this, right? And then I have reaction ratios. I have all kinds of reaction ratios that I can use. So for example, 1 frame is equal to 2 wheels. Or I could write 2 wheels. Oh, look at this. I wrote frames over here. Bicycles. Normally in class, people yell at me when that happens. 2 wheels equals 1 bicycle. That was nice. Or I could write something that goes just between frames and bicycles. Then it would be 1 frame is equal to 1 bicycle. I don't know why I keep doing that. All right, so like that. Now, here's the thing. I'm going to try this on you, and let's see how you do, okay? Let's say, now you're going to have to remember that balanced reaction. You have 5 frames in 8 wheels, okay? Now I'm going to pause it for just a second, and I want you to tell me how many bicycles you could make. Well, most of you came up with the idea that you could make 4 bicycles, right? Because what happens if you have 5 frames, you need 2 wheels for each. That'd be 10. You can't make that many because you only have 8 wheels, right? But then you also knew that, gosh, with 8 wheels I can make 4, and with 5 frames I can make 5, so I can only really make 4, right? So let me show you what you were doing in your head. What you were doing in your head was this. 5 frames, 1 frame per bicycle. That's 5 bicycles. In your head, you're doing this whole thing in your head. And then with wheels, right? If you had 8 wheels, you know there's 2 wheels per bicycle. Again, you're doing this in your head, and you're saying, oh, well, yeah, 8 divided by 2, because there's 2 wheels per bicycle, right? This is exactly this kind of thing you're doing. You're maybe not thinking about it, but that's how you're doing it. You end up with 4 bicycles. Now, most people will logically conclude you can only make 4, right? Because as you use up frames, you're also using up wheels. And eventually what happens is you run out of wheels, right? And notice the amount of bicycles that you can make is based on what you run out of. You don't run out of frames. In fact, you can calculate in your head right away that there's 1 frame left, right? So here's the deal. The theoretical yield is 4 bicycles. But in terms of sort of definitions, right? It's the amount, the maximum amount of product produced from the reactants. And you have, in this case, 4 bicycles. Now, there's a thing called the limiting reactant or the limiting reagent. Sometimes it's usually called the limiting reactant. The limiting reactant is what runs out. So the limiting reactant runs out during the reaction and limits how much product can be produced. So there's a theoretical yield, there's a limiting reactant, we also have an excess reactant, the excess reactant is the one that doesn't run out, right? So if you're trying to calculate a theoretical yield and you're only thinking about one reactant and you have a lot of other stuff, you just need to calculate from that one reactant how much product can be made, and that'll be the theoretical yield. On the other hand, if you're given multiple reactants, you really have to figure out for each reactant how much stuff can be produced. And the limiting reactant, right, you can tell because it makes the smallest number. So the smallest amount of product. Okay, so now, there's also something called the percent yield. So to do the percent yield, you need what's known as the actual yield. And actual yield is just how much you actually made. So to get the percent yield, you go like this. I'll call this PY, right? I'm going to call this TY. And this is going to be AY, the actual yield. Excuse me. So theoretical yield percent is the actual yield divided by the theoretical yield. Sorry, percent yield, sorry. It's also often called the percent theoretical yield. So percent yield is the actual yield divided by the theoretical yield times 100. So in this case, I made 3. I could have made 4 times 100, so that's 75%. Okay, so you have a 75% yield. So oftentimes this is the kind of thing that people are doing at their workplaces. They're saying, well, I know I'm going to inventory this much material. There's going to be a certain amount of loss. This is how much I'm going to get out. If you're packing fruit, it's the percentage that's bad. You try to estimate what that is so you can buy boxes and do all that kind of other stuff. Right? So you're always doing this kind of calculation regardless of what field you're in, figuring out how much you can actually get based on past history for like businesses, but for chemistry it's based on chemical reactions. Now the excess reactant, I talked about that one, that's the one that's left over, so that's this guy. So this is left over reactant after the reaction has completed. All right. So let's practice with what are known as mole to mole conversions.